So, good day everyone. Today we will going to discuss the industrial robotics for manufacturing. And before we begin, I would like to introduce myself and my group mates. I am Princess Ira Ferranco, together with Mr. Alan William Malapote, Mr. Benedict Acuña, Miss Charlene Bersimo, and Miss Mary Joy Briones. And for the table of contents, the definition of industrial robotics, the categories of industrial robotics, its advantages and disadvantages, the main components, creating industrial robotics, and the last is the type of industrial robotics. So, what is industrial robotics? The definition of an industrial robot system has evolved considerably in recent years. In order to determine what is industrial robot is, it is useful to consider the changes for their own origin to the present day. An industrial robot is one that has been developed to automate intensive production tasks such as those required by constantly moving assembly line. As large, heavy robots, they are placed in fixed position with an industrial plant and all other worker tasks and process revolve around them. So the characteristic of industrial robots will vary according to the manufacturers, the needs and the scenario in which they are to be located. And according to the international standard ISO of 8373 of 2012, the industrial robot definition is a multifunctional, reprogrammable, automatically controlled manipulator, programmable in three or more axes that can be fixed in one area or mobile for use in industrial automation applications. So, industrial robots are not usually humanoid in form, although they are capable of reproducing human movements and behavior, but with the strength, precision, and speed of machine. Moving forward for the category, today most robots are used in manufacturing operations. The application can be divided into three categories. These are the material handling, processing operations, and assembly and inspection. So for material handling application include material transfer and machine loading and unloading. Material transfer application require the robot to move materials or work parts from one location to another. So material handlings, uh, it is the movement of raw goods from their native site to the point of use in manufacturing, their subsequent manipulation in production process, and the transfer of finished products from factories and their distribution to users or sales outlets. So many of these tasks are relatively simple, requiring robots to pick up the parts from one conveyor and place them to one another. Other transfer operations are more complex, such as placing parts onto pallets in an arrangement that must be calculated by the robots. Machine loading and unloading operations utilize a robot to load and unload parts at a production machine. This requires the robot to be equipped with a gripper that can grasp part. Usually, the gripper must be designed specifically for the particular part of geometry. And the second one is the processing operation. In robotic processing operation, the robot manipulates a tool to perform a process on the work part. So for the example of such application includes spot welding, continuous or welding and spray painting. Spot welding of a automobile bodies is one of the most common application in industrial robots in United States. The robot position a spot welder against the automobile panels and frames to complete the assembly of the basic car body. Arc welding is a seam to be welded. Spray painting involves the manipulation of a spray painting gun over the surface of the object to be coated. And other operation in this category include grinding, polishing, and routing, in which a rotating spindle serves as a robot tools. And the last one is the assembly and inspection. The third application of industrial nga is it is the application area of industrial robot is yun nga, assembly and inspection. So the use of robots in assembly is expecting to increase because of the high cost of manual labor common in these operations. Since robots are programmable, one strategy is assembly work is to produce multiple products style in batches, reprogramming the robots between batches. An alternative strategy is to produce a mix of different product style in the same assembly cell, requiring each robot in the cell is to identify the product style as it receives and then execute the appropriate task for, for that unit. So the design of the product is an important aspect of robot assembly, as assembly methods that are satisfactory for humans are not necessarily suitable for robots. Using a screw and nut as a fastening method, for example, is um, easily performed in manual assembly, but the same operation is extremely difficult for an one-armed robot. Design in which the components are to be added from the same direction using snap fits and other one-step fastening procedure to work for the accomplished much more easily by automated and robotic assembly methods. And for the inspections, rather, in is another area of factory operation in which the utilization of robots is growing. In a typically inspection job, the robot positions a sensor with respect to the work part and determines whether the part is consistent with the quality specification. So, in nearly all the robotics applications, the robot provides a substitute for human labor. There are certain characteristics of industrial jobs performed by humans that identify the work as a potential application for robots. It first is the operation is repetitive, involving the same basic work motion every cycle. Second is the operation is hazardous or uncomfortable for the human worker. Example given is yun nga, spray painting, spot welding, arc welding, and certain machine loading and unloading tasks. Third is the task requires a work part or tool that is heavy and awkward to handle. And the last one is the operation allows the robot to be used onto two or three shifts. So, moving forward to the advantages and disadvantages of industrial robotic, it will be going to discuss of one of my group mates. It's Mr. Amis Charlene Barcimo. That's all. Thank you.
So I'm Miss Charlie Barsimon. I will tackle all about advantages and disadvantages of industrial robotics. Today's industrial robots work in a wide range of industries, from semiconductors and automobiles to plastic processing and metal forging. Pretty much any repetitive operation is the great job for a robot, particularly if it is dangerous or difficult for people. The application of robot is the manufacturing industries in particularly valuable. Robots have been used to high volume operation, but as the technology advances and the cost of industrial robot decline, more options and opportunities are opening for medium and small size operation. At the same time, these robots are helping manufacturers address many of the key challenges they face, including tight labor pools, global market competitiveness, and safety. If you're curious whether a robot can enhance your value stream, here are the main pros and cons to consider. Advantages. First is a better quality and consistency. Along with other techs such as the Industrial Internet for Things, ILOT, or 3D printing robots, industrial robots are able to provide better production quality and more precise and reliable processes. Added benefits are include reduced cycle time and real-time monitoring to improve preventive maintenance practices. Second is maximum productivity and throughput. An industrial robot increases speed for manufacturing processes, in part by operating 24/7 Robots do not need to break the ship changes. The speed is the dependability of robots ultimately reduce cycle time and maximize throughput. Third is greater safety. Using robot for repetitive tasks means fewer risks the injury for workers, especially when manufacturing has to take place under the hostile condition. In addition, supervisor can oversee the process online or from remote location. Fourth is reduce direct labor costs. The cost of having a person handle manufacturing operation is often more expensive than robot. This can also free up the workers so their skills and expertise can be used to other business areas such as engineering, programming, and maintenance. Last is keeping manufacturing in the US. Some argue that robots are taking jobs away from US workers, but that's not necessarily the case. Industrial robots, these are typically integrated in the series of operation that requires human expertise. For example, you could have the robot welding parts that are handed off the person to perform a task that requires a human, intuitive, if-then thinking. Disadvantages of industrial robot. First is the high initial investment. Robot typically requires a large upfront investment. As a research your business case for purchasing, consider all the costs of industrial robots, including installation and configuration. You should also evaluate whether your robot can easily modified if you need to alter operation in the future. Second is expertise can be scarce. Industrial robots need the sophisticated operation, maintenance, and programming. While the number of people with these skills are growing, it currently limited. As a result, it's important to consider the personal investment you need to make the bring in that expertise up pretol your existing staff to take on the task. Third is ongoing cost. While industrial robots are reduced, some manufacturing labor costs, they come with the other ongoing expenses such as maintenance. In addition, you never want to consider the cost to keep the robot and any related IoT connected devices protected from cyber threats.
The four main components of an industrial robot are the manipulator, the controller, the human interface device, and the power supply. The manipulator is the arm of a robot and like a human arm that has several joints. These joints or mechanical linkages are capable of movement in various directions to perform the work of the robot. Additionally, the body, arm, and wrist assembly is sometimes called the manipulator. The arm and body joints of the manipulator are used to position the end effector, and the wrist joints of the manipulator are used to orient the end effector. The robot controller is a computer composed of hardware and software linked to the robot and essentially functions as its brain. Controllers have all of the characteristics associated with computers and contains sophisticated decision making and data storage capabilities. One input may come from the human interface device, such as a touch pendant. These devices can be used to program the arm and control its movement. The last component is the power supply, which is where an industrial robot gets its energy for its controller and actuators. This is typically in the form of electrical energy.
Creating industrial robotics. Industrial robotics are crucial to modern manufacturing process. With their precision, speed, and reliability, creating an industrial robot involves expertise in mechanical, electrical, and software engineering. Here are the steps involved. The first one is identify the purpose. Identify the purpose is the first step in industrial robotics. This involves determining what specific tasks the robot will be performing in manufacturing or industrial setting. Identifying the purpose of something means recognizing why it exists or is being used. For example, industrial robotics, it means understanding the specific tasks the robot is designed to perform, such as assembly, welding, or inspection. This is important for using the technology effectively and avoiding inefficiencies or safety hazard. The next one is design the mechanical structure. Once the purpose of the robot has been identified, the next step is to design the mechanical structure of the robot. This involves selecting the appropriate materials, motors, gears, and other mechanical components that will be needed to build the robot. In designing the mechanical structure naman, it refers to the process of creating a physical framework or body for a machine or device. It involves creating a durable and strong body for the robot that can withstand the force it will encounter while performing its specific function. And it is an essential step in creating an effective and efficient robot that can perform its intended tasks precisely and reliable. The next one is design the electronics. After the mechanical structure has been designed, the next step is to design the electronic components of the robot. This includes selecting the sensor, controllers, and other electronic components that will be needed to control the movement and action of the robot. In design the electronic device naman, electronic pala, it involves creating the electrical and electronic components that allow a machine or device to function. It means designing the system that control the robot's movements and enable it to perform its specific tasks. This involves selecting electronic components, integrating them into the robot, and programming the robot to perform its tasks accurately and safely. The next one is write software code. Once the mechanical and electronic design have been finalized, the next step is to write software code to control the robot. This involves programming the robot to perform the desired tasks such as moving material or welding pieces together. Um, in writing software code naman, is the process of creating instruction in a programming language to tell a machine what to do. It is a critical step in creating an effective and efficient robot that can help and perform its specific tasks accurately and reliability. The next one naman is assemble and test the robot. Um, test the robot involves after software code has been written, the next step is to assemble the robot and test its performance. This involves connecting all the mechanical and electronic components together and then testing the robot's movement and action to ensure that it's performing the desired task accurately and reliability. Assembling and testing the robot involves physical putting together the mechanical, electrical, and electronic components of the robot and verifying that they function as intended. This process ensures that the robot can perform its specific tasks accurately and efficiently while interacting with its environment in a safe and controlled manner. The next one is and the last one is refine and deploy the robot. After testing the robot, any issues that are identified are addressed and the robot is refined until it meets the requirements performance standards. Once the robot has been fully tested and refined, it is deployed in manufacturing or industrial setting where it will be used. Refining and deploying the robot involved making final improvements to its design and functionality, and then deploying it for use its intended environment. And this include optimizing performance, increase efficiency, and ensure that the robot operates safely and reliability in its environment. In conclusion, creating an industrial robot requires expertise. Expertise in multiple engineering disciplines, from designing the mechanical structure to writing the software code and refining the robot's performance. Each step is critical as the demand for automation in manufacturing continues to grow. Industrial robotics will play a significant role in driving efficiency, productivity, and innovation.
So, types of industrial robotics. So, we have the articulated robots, SCARA robots, Delta robots, and Cartesian robots. So, kapag sinabi nating articulated robots, um, articulated robots are is a mechanical movement and configuration closely resembles a human arm. The arm is mounted to a base to a, the arm is mounted to a base with a twisting joint. So the arm itself can feature anywhere rotary joints up to 10 rotary joints, which act as axes, with each additional joint or axis allowing for a greater degree of motion. So most of articulated robots are is utilized for or six axis. So typical application for articulated robots are assembly, arc welding, material handling, machine tending, and packaging. So sa Scara robots naman po uh, a SCARA is an acronym that stands for Selective Compliance Assembly Robot Arm or Selective Compliance Articulated Robot Arm. So, ang SCARA robots po is a function or three axis. We have the X, Y, and Z. And meron po siyang rotary motion as well. So, is SCARA robots excel in lateral movements and commonly faster moving and have easier integration than Cartesian robots. So typically, SCAR robots are used for assembly and validating as well as biomed application. So we have the Delta robots. A delta robots or parallel robots possesses three arms connected to a single base, which is mounted above the workspace. So delta robots work in a dome shape and can move both delicately and precisely at high speed due to each joint of the end effector being directly controlled by all three arms. Now, delta robots are often used for fast pick and place application in the food, pharmaceutical, and electronic industries. So, last one is the Cartesian robots. Cartesian robots, which are also called linear robots or gantry robots, are industrial robots that work on three linear axes that use the Cartesian coordinate system, meaning they can move in straight lines on three axes. So Cartesian robots are popular choice due to being highly flexible in their configurations, giving users the ability to adjust the robot's speed, precision, stroke length, and size. Cartesian robots are one of the most commonly used robots types for industrial application and often used for CNC machine and 3D printing.